3.3 Future value of an annuity and sinking funds. Okay, let's define first a couple definitions. The first one says an annuity, so that's an annuity is any sequence of equal periodic payments. Okay, so up until this point, 3.1, 3.2, simple interest, compound interest, we were only making one payment. So let's just write that as a note. 3.1, 3.2, there was only one, and we've been calling them like investments. Right, we only went one time to the bank, deposited money, walked away, let time go and pass, and then we'll come back and then there's interest earned on our initial deposits. But now in this section, 3.3, we're talking about a sequence of equal periodic payments. So that means, hey, on the first of the month, we're coming back to that bank account over and over, depositing 500, 500, 500, or whatever that amount is. Okay, so that's how you distinguish an annuity problem between what we were dealing with 3.1 and 3.2. If payments are made at the end of each time interval, then the annuity is called an ordinary annuity. And we'll only be considering these types of annuities for this class. Okay, another definition, the amount, or we've seen this word, future value of an annuity is the sum of all payments plus all interest earned. Okay, and let's just star this note. This is how we will determine if we have a future value problem versus 3.4, a present value problem. So for any future value problem, payments or deposits are being made into the account that is increasing in value. Okay, so you have this account that's going up and up and up by every payment you're putting in there. Alright, future value of an ordinary annuity, this is FV, so that's one variable, is equal to PMT, that's another variable, and then we have this big quotient inside. Okay, so a scary formula, but it's not too bad, and I'm actually going to give you this formula on the exam. Okay, so no need to memorize this, but the other formulas we've dealt with, 3.1 and 3.2 formulas, you're going to want to know those and memorize them. This one will be given to you on the exam. Okay, so FV, this is the future value, this is the amount, so it's a dollar amount. PMT, that's one variable. These are the equal periodic payments that we're throwing into the account, right? If we come back to the first of the month example, we're throwing 500, 500, 500, 500 every first of the month. Okay, R is our usual interest rate, so look for that percent symbol. M is that same number of compounding periods per year, and T is time in years. Okay, let's look at our first example. This says, what is the value of an annuity at the end of 20 years if $2,000 is deposited each year into an account, earning 8.5% compounded annually? How much of this value is interest? Okay. Well, we're making our $2,000 deposit each year into this account. So, let's just think about this. If you go to your account, your savings account in your bank, and you deposit $2,000 each year, what's going to happen to that account? Well, yeah, the account has to increase. So the account is going to increase based on these $2,000 deposits you're going to make every year. So from our note that we start up here, if the account is increasing in value, then we know we have a future value problem. So we'll just put a little arrow and say this is a future value problem. Okay, it's obvious that it's a future value problem because we are lecturing in 3.3, but come time from the test, I'm not going to say, hey, this is a future value problem. You have to read the contents of the problem and put it together. And so that's why I am highlighting, emphasizing that, hey, this sentence right here is the one that tells us that we have a future value problem because we are depositing 2,000 in account each year, and that account is increasing in value. So once you know that this is a future value problem, then your next step, as always, write out that formula that you're going to use. Don't plug in values until after you write out the formula. Alright, now that you know that this is a future value problem, let's list out our variables. So here, this is asking us, what is the value of this annuity 20 years later? That's our future value. That's what's going to happen in the future. We do not know that, so we're going to put that as a question mark. How long are we making these payments for? 20 years. So T is equal to 20 years. Our PMT is 2,000. And again, that's from that highlighted part that we have written if 2,000 is deposited each year. Our interest rate, look for that little percent symbol. Convert this over, so we're going to get 0.085. And then we see our keyword of compounded annually. Okay, so since this is compounded annually, we're going to have 1. Alright, so now that we know what we're solving for, let's just go ahead and plug in our values. So this will be FV is equal to, payment is 2,000. And then we're going to work inside of here. We're going to do 1 plus 0.085 over 1 raised to the 1 times 20 minus 1. Now this is all over 0.085 over 1. Alright, so let's take it one step at a time. We're going to work with the most inner parenthesis. So we have these sets of parentheses, but then we also have these sets of parentheses. So we're going to work with the second set of parentheses that I have right there. Everything else will stay the same. So FV is 2,000. And this inside part, we're going to punch into our calculator 1 plus 0.085 divided by 1. Or if you already saw that without the calculator, you could just put that as 1.085. And that's going to be raised to the 20 times 1, and we can just say, that's 20. Minus 1, all over 0.085, right? 0.085 divided by 1 is itself. Okay, now that we got rid of our second set of parentheses, we're going to be zooming in on the first set of parentheses. And now we're going to simplify the numerator and denominator. The denominator is already simplified for us, so we just got to simplify that numerator. So we're going to go ahead and type in our calculator 1.085 raised to the 20, hit enter, and then just subtract that 1, minus 1, enter. And we should be getting 4.112046125 all over 0.085. And if you still have that long 4.112046125 in your calculator, you can simply hit your division symbol and then just divide it by your denominator, which was 0.085. And that is going to give us 48. So you can say FV is equal to 2,000 times 48.377 0.01323, and then if you still have that number in your calculator, just hit multiplication, because we're going to multiply that by 2,000. And this should give us an FV of $96,754, and round to the nearest Lincoln, 0.3. Alright, so then we're going to go ahead and write our sentence over here. We're going to say the value of the annuity after 20 years is $96,754.03. Okay, so the second part of this question is saying, hey, how much of this value that we found is interest? Well, if we did not trust the banks, so let's say we are not a bank person, we don't want to deposit our money into the bank, then if we were storing this money in a vault in our house, we're going to be making $2,000 payments each year. Okay, so when the year 2020 is over, we're going to deposit $2,000. When the year 2021 is over, we're going to deposit another $2,000. And we're going to do this for 20 years. So your total amount after 20 years, well, that's going to amount to $40,000. And this is what you would find in your vaults underneath in this underground bunker that you don't want anybody to know where your money's at. Okay, so the total interest that the bank is giving you would be the difference between these two. So total interest would be $96,754.03 minus $40,000. And when we punch that into our calculator, we're going to end up with $56,754.03. This is the total interest earned. Right, because if you are depositing this money into your bank, not into your bank, if you're depositing this money into your underground vault, well, no one's going to give you interest, right? If you take this money to a bank and you let it sit there and you keep depositing this money, well, there's going to be interest earned. The bank has access to your money, so they're going to give you some money, interest, for letting it sit there. So it's a pretty good chunk of interest earned if you take the bank approach. Okay, let's look at this next example. Here, the Hartford offered an annuity that pays 3.5% compounded semi-annually. What equal semi-annual deposits should be made into this annuity in order to have $250,000 in 20 years? Alright, just like before, what we're doing is we're doing semi-annual deposits. So if we're depositing money, the account is increasing. So this tells you that we have a future value problem. Okay, so that should always be step one, is figure out if you have a future value problem or a present value problem. Present value problems will come about in 3.4. Alright, so since we know we have a future value problem, by that part I bracketed, we're going to have the same formula. So go ahead and copy and paste that formula. And then we know that these are going to be semi-annual deposits. So semi-annual will be 2, right? There's 2 halves in a year. And it's compounded semi-annually. Our R, that 3.5%, which will be 0.035. Here, this one is saying what equal semi-deposits should we make? Okay, so that part that I have highlighted, that's the PMT. These are the ones that you're going to keep coming to the bank every half a year and deposit that same amount. We do not know how much that is. Okay, however much that is, we know that we want to have $250,000 in this account over a span of 20 years. Alright, so let's go ahead and plug in our values. 250K. PMT we do not know. 1 plus 0.035 over, and here it's 2, and that's going to be raised to the 2 times 20 minus 1 all over 0.035 over 2. Alright. Just like before, this looks like a very scary, nasty formula, but just follow the orders of operation and simplify as best as you can. So here's one set of parentheses. I see a parentheses inside of the parentheses, so work with the most inner set of parentheses, which are these. So when we punch this part into our calculator, 1 plus 0.035 divided by 2, that is going to get us 1.0175, and it's going to be raised to the 2 times 20, or simply we can just write that as raised to the 40. And then we're going to do minus 1 divided by, and then we're going to have in our denominator 0.0175, and then we're going to have our PMT and then our 250K. Alright, so now let's simplify that numerator. 1.0175 raised to the 40, so if we punch that into our calculator, we're going to get 2.0015973343, but subtract it by 1 because we have this minus 1 right here. So let's just simplify that completely, and that should give us 1.001597343. That's going to be divided by, we didn't touch this denominator, PMT, and then 250K. Alright, now let's simplify this portion. If you haven't pressed anything else in your calculator, you can just hit the division, because 1.001597343 should have been the last value in your calculator. So hit that division and go 0.0175, and that should reduce to 57.234139, and notice I am not rounding until the end because every penny counts. Alright, and then our last step for solving this, we're just going to divide both sides by that. 57.234139 to both sides to isolate PMT. Cancel, cancel. PMT is equal to, we can type in 250,000 into our calculator, hit division, and then if we want to be sneaky about this, hit the second button, and then look for this little minus sign. It should be to the bottom right, to the left of the enter button. and then it's going to say ANS. And so what that's going to do, that's going to take the line previous from your previous line, and it should take that line of 57.241339, or you can just type it in, whichever you prefer. In any event, your final payment amount should be $4,368.02. And then we're almost done. As always, we should make $4,368.02 payments semi-annually over 20 years to have a future value of, to have a $250,000 amount in your account. So we should make this $4,368.02 payments semi-annually, right? So every half year over 20 years to gain, or to have this annuity that's going to be worth $250,000.